Okay. As I was saying, what we're going to do is examine these using Desmos as a slider. Okay. Now that part isn't going to get recorded, but the information part will. So, okay. So, either tell me or chat with me. Tell me some things you noticed about the graphs as you slid the N. And anything's good. There's not going to be any wrong answers here.
As I slid the slider, the even numbers had the U-shaped, and the odd numbers had like a slide. I don't know how to explain it, but yeah.
Okay, so N is even. Then we got like a U-shaped graph. And if N is odd, I don't know how to describe it either. I've been trying to figure that out for a long time. I just kind of call it a little squiggle. Okay, that's great that you noticed that. That's what we're looking for there. Okay. How about some other ideas about maybe the domain of ranges or anything like that?
They all seem to have all real numbers for the domain.
Yeah, I think you're right. The domain for all these are all real. It's good. So domain for this one was all real. Okay. Well, what about the ranges now? Let's look at those. How about for the evens over the ranges? And you can chat it too if you want. Send it to me privately if you want to. So if we have a U-shaped graph, what's the lowest that graph goes on the y-axis? What's the lowest point?
0?
Yeah.
0 or the origin.
Right, 0 or the origin, right? So that means that our range has to be greater than or equal to 0. Now, for those of you who like that interval notation, we'd have 0 to infinity for that, right? Yeah. Okay. Now this one is this squiggly thing, right? So what's the range on that?
Infinity?
Mm-hmm. Yeah. Infinity to infinity are all real numbers. Okay, so you could go like this. Sure, they mean the same thing. So these are called power functions. And that's how they work. Okay, there are other types of power functions. I gave you ones that were where n was an integer, or not even an integer, a whole number. Okay, but there are some power functions where that are considered if you have some negatives or if you have some, well, I guess just the negatives would be your powers. Okay. But I didn't do any of those. I just wanted to keep it like this. So those are powers. All right. Let's look at these ones now. These are called root functions. Okay. Root functions. And they would be sort of like this, where this is an n. All right. So it's going to be the same thing. All right. We're going to type that in the decimals. I'm going to show you how. And we're going to slide it around. Use the slider. See what happens. All right, so I'm going to stop sharing this. Again, I'll come back to it. So I'm going to go y equals. And then your functions here have that little square root in it. It's all the way to the far right, miscellaneous, and there it is right there. So I think if you're using your phone, you hit functions. I think it says func, F-U-N-C, and then you would go to miscellaneous, and it should be right there, square root with an N. And then we'll put an N in there and introduce a slider. Oh, I got to put an X right there. There we go. And this time I want to do the same thing. All right, so we're going to go from 1 to 6 by 1. All right, so let me go back to this so you can see it. There it is. Okay. I'm going to stop sharing. Slide away. Answer the same question. What happens to the graphs? What about, is there any patterns? Is there domain and range things going on? There we go.
Can you show how you put it into Desmos? Mine's not working properly.
Sure. So we went y equals.
Y equals, okay.
And it's like I said, yours is on your phone's probably going to be FUNC. And you want to come over here to miscellaneous. And it should be right there.
Oh.
And then you want to put N and then an X in here.
Got it. Okay. Yes, thank you.
You're welcome. All right, so again, all right, we're looking for patterns of things that happen when you slide in. What'd you find out?
When you put even numbers, it goes from 0 to like a positive, like forever. I don't know. It goes to the right side forever.
Okay, so when n is even,
It starts at 0.
It starts at 0, and I bet it
Yep.
goes like that, right?
Yep.
Okay, cool. What happens when it's odd?
It's like the same thing as a power function, but it's a different side. It goes from left to right.
Okay. Who was telling me this?
Veronica?
So, Veronica, that was really, you made a huge connection there. I don't know if you knew that or not, but on what you just said, that this one is a lot like the power function, except that it's been switched to left to right. And that is exactly correct because they are related. So we would say that the root functions are inverses of the power functions. Okay, so because of that, they are related, and you can see that you're kind of getting the same type of shape, like you said, on the odd one. All right. Now, if I was to take this even one, I could make a U out of it, but the problem is if I do make a U out of it, it doesn't pass the vertical line test. Okay, so it still is an inverse of it. It's still related to the even power function. Well, that was good observation there. Nice job. All right, cool. So what about the domain and range of these things?
Oh, well, the domain is from 0 to forever. And range is 0 to forever, I guess.
Okay, so that's for the evens. And what about the odd then?
All real numbers.
Oops, I don't need that. For both?
Yes.
Okay. So that's awesome. So if you guys picked up on that, that's great. The domain and range is all real for the odds, and greater than or equal to 0 for the evens. All right? Yeah. So that's what a root function looks like. Okay, we call it a root function because obviously it's a root, but they are related to the power functions. So what a great connection. Okay, good deal. We're cruising along. All right, now let's do one more, and then I'm going to give you that break. All right, so these are called rational, and I kind of mentioned that before, is that these rational functions are something that they deal with in chapter 3, but they're going to introduce it here, so it looks like this. All right. Now, I could put a power on it, but I don't think I'm going to. I'm just going to leave it as y equals 1 over x. So we're just going to set that up to graph it. And we'll go from there. All right. So I'm going to stop sharing this. This time I'm actually going to pause. So that's kind of what it looks like. Now you said the domain is everything, but it's not 0, so x cannot be 0. And the range, same thing. Now, I've seen some people in the past write that out as interval notation. And you could, but it seems kind of like a lot of work. I mean, you just got to write a lot of stuff. So that there's what we wrote is works pretty good. Now, all rationals are kind of like that. Okay? And they're kind of related to the power functions, but not really. They're sort of in their own little group there. So again, the idea here is that if I was to give you a graph and say, here's a graph, how would you best classify that? Is it a power? Is it a rational? If it's a power, is it even or is it odd? That's the kind of thing we're looking for. What's the domain and range of it? Okay. All right, so 7:05, been here an hour. Let's take a quick break. Come back at about 7:15. Okay, and we'll do some more of these. Resume this. Come on. There we go. All right, so the next one we're going to take a look at is called an absolute value function.
Ooh.
All right, so now let's go ahead and just graph that one. So we're going to do pretty much, some of these aren't just going to have any sliders right now. We'll introduce some more sliders later on when we get to 1.5. But for now, let's go ahead and look at this one. All right, so I want to stop sharing here. And let's go to Desmos. So to get to an absolute value function, there's actually a couple of ways to do it. You can do y equals, and the little function is right here. Okay. Also, you can type ABS, and it will know what that is too. All right, so there's absolute value. Now, who can tell me what absolute value does, first of all? Can somebody either tell me or chat me what it does? In basic terms there.
Doesn't it like flip the x and y? I can't remember, but is that what it is?
Well, there's some flipping going on there, definitely.
Is it when the x is negative, it turns it positive?
Yeah, you're really close there. So yeah, what happens is if we just take the absolute value, for example, of 5, we get 5. But if we take the absolute value of -5, we also get 5. So it's a distance, right? I think I said something like, if you go from Hillsboro to Portland, that's however many miles that is. And then Portland to Hillsboro is the same miles, it's different direction. So the distance is the same, but the direction might be opposite. Right? So that's kind of what's happening there. Okay, so that's what absolute value does. So here's our graph, right? Interesting. Okay, and so what is the domain?
All real numbers.
All real numbers. Okay, all real numbers. What about the range?
0 to forever.
0 to forever. Okay, so the absolute value, sort of like a power function, an even power, but it's a V. Okay, so we have a V shape. So we want to be able to distinguish between a U shape, nice curve, and a V shape. All right, so V shape is your absolute value graph. Now, while we're in the absolute value graph, what the heck? Let's go ahead and do another one. All right. Well, actually, that's not, because that's going to be. Let's go like this. Do they have? No, they don't. Okay. I'm going to introduce another one, I think. Oops. Because it really should be included. So the absolute value graph looks like a V. And the domain you told me was all reals. We get a lot of domains of all reals. That kind of happens. And here we're going greater than or equal to 0. Okay. And there we go for those that like the interval stuff.
How much different functions are there?
Oh, quite a few. I mean, as far as what we're going to do is we're just about done. We'll probably do 3 more. I want to definitely, yeah, we'll do 3 more, I believe.
Okay.
Okay, so I'm just going to stop this. All right. Oh, my bad. Let me go back to this again. Sorry. The next one I want to look at, and it's not in your book, is an exponential. Now, an exponential, we've heard a lot of lately, right? So it sort of looks like that, okay? So A is a number, right? So A is just some sort of a real number. So what we'll do is graph it. Now, most of you are probably pretty darn familiar with exponentials. All right, we'll go ahead and take a look at it. Y equals, again, I'm just going to kind of pick a number. I'm going to go with 2 to the x. So here's an exponential, all right? And obviously, we know exponentials have one big characteristic. It looks sort of like a U shape, except, or power, even power, except of course it doesn't have the U on the backside. But if I was just to show you this, you'd say, oh, that's a U shape. Probably would. But one thing about an exponential versus a U is that it grows faster. Okay, so if I was to come down here and put in y equals x to the n, I mean, we're pretty close there to where it's growing. So, I mean, we'd have to get here, and even after a while, the exponent's going to catch up to it. See that? Eventually, they're going to catch up. So an exponential grows quite quickly, all right? And let's look at this. It's kind of interesting. So what about the domain? What do you think a domain of an exponential is?
All reals?
All right. So it gets really, really close, but never really hits it. Not drawing it very well. Okay, so the domain you've already said was all reals. But this time the range is just greater than 0. So instead of having a bracket, we're going to have a parenthesis on that. That one you won't find in this section, but it should be. Okay, next one. I want to stop this and just jump right into decimals on this. And I want to have you actually do a little bit more here. Okay, we're going to go like this. Y equals. We're going to come into functions. And we're going to work with these three. All right, it's under miscellaneous. There's one that says seal, floor, and round. So for example, if I go seal, I put an X in there, it gives me a graph. All right, we're going to do the same thing with all three of them. I wouldn't recommend you do them all at the same time. Do them differently. All right, so again, seal, floor, round. Type them in, graph them. Again, look for some patterns. What's going on with the graphs? What do you notice about them? Domain and ranges. Same as before. Seal, floor, round. We'll give you a few minutes.
So should we just put X in the parentheses?
Yes. Yep. Is called the greatest integer function. And the greatest integer function is just like floor, and it's going to round down. And they symbolize, I'm looking to see how they symbolize it in here. They call it INT X. I've also seen it like this before, where it's a bracket and a bracket and an X. Okay, but it's just like floor. It's going to round down. So you can see that it takes, like here's 1, okay, and it puts a solid dot here and an open dot there, and it's, okay, so then it's, all these decimals are rounding down to 0 until it hits 1, and then as soon as it hits 1, it comes up, and then that would be 2, this would be a 1 here, and then the same thing, right, you get this sort of action here. Okay, that's the greatest integer function. So if you see that like this, and we would go say 1.5, then we know, hey, that's the same as floor. It's going to round that down to 1. All right. Okay. Hey, domain. What's the domain?
All real numbers.
Good job. All real numbers. And the range?
All real numbers.
Oh, everybody agree with that?
It's greater than 0.
Okay, I got all real numbers and I got a greater than 0. Johnny's telling me he doesn't agree with that. What do you think? What is it then? I like your thinking here. What is it? Remember,
Equal to 0?
think of the eggs, right? All integers. Very good. Nice job. So these are going to be all integers. Okay, because we're not going to have any decimals and we're not going to have any... All right, no fractions, no decimals. It's just going to be all integers. Nice job. Yeah, we don't care about the word. You got it. You nailed it. Good job. Okay, so that one's a little different, right? I mean, most of them, we've never had one like that. Okay. All right. So hang in there. We're just about done here. We're going to do one more, and then we're just going to take a peek at 5. So the next graphs we're going to take a look at are called piecewise functions. Piecewise functions have applications in taxes, parking, shipping, anything that has a difference in cost at certain levels. Okay. So I'm just going to show you what a piecewise function looks like, and then we'll talk about it.
Wait, didn't your domain and range for step functions? Does that mean that they don't have one?
Oh, those step functions should have all the same.
Like seal, floor, and round?
Yeah, but they should all have the same domain as all real numbers, and the range should be all integers, because they're all pretty much the same.
Oh, alright, okay, got it. We missed that.
That's all right.
Ooh.
If I could get my thoughts corrected here, we'd be all right. Okay, this is what a piecewise function looks like. All right, they can have as many pieces. They can have 2 pieces. They can have 3. This one has 3. You could have 10 if you wanted to. All right. But they're called piecewise functions is because they're divided into pieces. So this is a piece, this is a piece, and this is a piece. Okay, so they always have a function and a condition. All right, so it's divided up into 3 things. So what I'm going to do is just kind of graph this and give you an idea of what it looks like. And we'll graph it in Desmo so you kind of see what it looks like there. All right, and then I'm going to see if you can kind of design your own little piecewise function to come up with something. So that's where we're going with this. And the domain and ranges could be all over the place on these, so let's take a look at this. So this says that if I am less than -1, then I'm going to use that function. All right, so I'm just going to go ahead and put a -1 here, and a -2 here, and a -3 here. All right, so I'm just going to go ahead and start at a -3. Well, that's going to mean I'm going to put -3 in for x. -3 plus 3 is 0, so I'm going to put a 0 there. All right. Now, if I put -2 in for x, I get -2 plus 3, which is 1. -1 is going to give me that. So I'm going to get a line. All right, and this line is going to continue to go down like that. But as soon as I get to -1, something changes, right? I have to use the absolute value part of the graph. Okay? So now things change. I'm going to change this to black here. There we go. Or whatever color this is. All right, so from -1 to 1, I'm going to use a V-shaped absolute value graph. So that means that now this is 1 here, and this was 2. Okay? So this one, I'm going to put a dot right there. This one has to have an open dot, by the way. And then it's going to be a V shape, right? So it's going to go like this. Goofball. All the way to 1. So it's going to look like that. Okay. Then at 1, right after 1, now this graph is over. Okay, and it's going to concentrate on this one because that's what the condition says. So now I'm going to have x plus 3 again, but this time that's going to happen after 1. So I'm going to just kind of go ahead and look at 2 and look at 3. So 2, I'm going to get a 5. So there's 3, 4, 5, right? And 3, I'm going to get a 6. So this graph's going to come down to about there, where it's going to be an open dot, and I'm going to get something that looks crazy like this. And that's called a piecewise function, because it's defined in pieces.
So we can or cannot use decimals for this?
Oh, we can. I want to show you here in a little bit.
Oh, okay, because this didn't really make any sense.
Oh, I know. Piecewise functions are kind of weird. Okay, so let's try it on decimals. Now, when you do it, here, let me show you something, okay? Orange. This function has the function first and then the inequality. In decimals, it flips it. Now, I don't know why they did it that way, but it does. So it does the inequality first, then the function. All right, now I'm going to show you what it looks like.
Same line, but I don't know how to describe it. It's
sloping the different way, right?
right, descending.
Yep. So we'll put a negative in front of that, and that will help get that to work. And this is going to be greater than, but not equal to. Just greater than 2. Okay. So something like that is going to, we might have to mess around with those line functions a little bit to get them to work. But something like that is what a piecewise function is going to look like. Okay. I really think that all you're going to be doing with them is graphing them. And I showed you how to enter those in the decimals. And finding some values of them. All right. So if this was the case, and we want to find the value of -4, right? Then what we'd want to do is see, okay, which condition does -4 meet? Does it meet this condition? So it would be the top one, the middle one, or the bottom one. Which one does the -4 fit? Which condition?
The x is less than -2.
Right, the top one. Okay. So then I would just go ahead and follow what that says. Okay, so then that means that I would put -4 in for that x, and I would get -4. Now, obviously, we'd have to alter this thing a little bit, but that's what you're going to have to do. So then if we do f of, say, 0, all right, now, do we do the top, middle, or bottom condition? Which one?
0. The middle.
The middle condition, right? So then that would be y equals x squared, where x is equal to 0. So that gives you 0. Okay. So those really all you're going to have to do with piecewisers is just kind of work with them a little bit. All right, graph them, talk about domain and ranges. You should be okay with them though. You could just type them in.
The example really helped. I got it.
Okay, good. As far as showing work on homework, it's your homework is what, 10 10%, 15%, I think, of your overall grade. And it's, I'm just going to go through it and look at it, make sure you did it, check for correctness, that kind of thing. So I don't think you need to show a whole lot of work on that. It's just practice, all right? I mean, I shouldn't say that, but it's kind of what it is. When we get to quizzes, which is what we'll take on Wednesday, and we'll do that on DTL, then you want to try to show me some stuff, because those problems will be worth 2 to 3 points, and those are the ones I'm looking at and saying, okay, where did I not convey the message to you? So yeah, on those ones, tests and quizzes, I would definitely want to show some work. On the assignment, just give me some answers. I think that's pretty much how I would handle that. Is that good?
Yes, thank you.
Yes, awesome.
Great.
What is your policy on retakes and stuff?
I kind of don't really do any types of stuff like that. I know somebody asked me a little bit about extra credit too. I've tried, I'm just I'm just being honest with people. What my past experience has shown me with PCC math classes is the people that come to class almost all the time and do their work for the most part are fine. It's when you miss class that it just comes back to hurt you. So and not kind of doing. I mean, doing the homework is definitely important. If you miss one or two, you're probably okay. But if you start falling behind in math, kind of get you. So I try to make the assessment not too heavy on one end. The quiz is a test. We got a couple of those activities spread in there. So that tends to be, I guess I don't get a whole lot of people telling me in my evaluations, hey, you should have gave me extra credit, or hey, we should have been able to do retakes. So I don't usually get a lot of that. So I don't have much more else to say. I don't think we'll do anything with 1.5 tonight. We'll just do some stuff with it tomorrow, or sorry, Wednesday. We'll still have that quiz though, and we'll kind of see how we do on it. But I want to stay here, and if you guys have any questions you want to ask me, just through here or chat or whatever, I'll be available for you. Otherwise, you can enjoy the rest of your evening. I'm sorry, go ahead.
Will what we learned today, will that be on the quiz for Wednesday?
I don't think I found a way to quiz you on that. It's hard to do it to come up with these questions. So no, it'd be mainly the stuff from last week. There might be something, but it would be, you might see a power function. It'd just be asking you domain and range and stuff, right?
Yeah. Okay, thank you.
Yep.
I have a question. How are we going to be accessing the textbook?
You're welcome. Thank you. Go ahead. I'm sorry.
The textbook, it still says I need to register the class code and it wasn't the
CRN.
Yeah, it wasn't the CRN.
Okay. Oops.
Do you think I might be able to rent it from like a library or something?
You'd be able to do what now?
Do you think I might be able to rent it from like a library? Do you think they might have textbooks like that?
Oh, like a textbook for this one in the library? Jeez, I don't know. I wish I had an answer for you on that.
Yeah, mine's giving me try to get an access code, but I'm not sure what that is.
I'm looking on here to see if I can find my access code. I remember seeing that somewhere. Nobody else mentioned that, though. I wonder why. So I'm going to email the person that helped me and see if they can tell me where the access code or what the access code is.
And also the course number. It asks for a course number and an access code.
So is the course number not the CRN?
Oh no, I tried it and it said that there was no results.
Oh my goodness gracious. Okay. Well, I wish I could answer your questions. So we're having access code and a... See, that could be what they're saying is some of the problems with what the emails are. I'm going to... Where is she at? Right here. Okay, I'm going to email her and so can you guys email me that are having the issues with the access code and the course number so I can give you that information when I hear back?
Yes, I will also take a screenshot of the screen that of the Pearson, what we see from our end.
Okay, yeah, you can, and then if she gets confused, I can send that to her. Okay, sounds good. Try to be while you're here now.
I had a quick question.
Yes.
This might be kind of stupid, and again, a little late, and I do apologize. But for problem number... actually, hold on here for a second. I'm getting a phone call.
That's okay.
Hello? My phone died.
Okay, thank you. Good night.
Good night.
Math problem 47 on our first homework assignment. Did you want us to do every single function for it?
So is that on page 1.1?
Yeah. So there's f of 0, f of 1.
Yeah, I see all those. Right. Well, no, now 47, you're just finding a domain.
Oh, you're just following... Hold on, are we on the same page?
54.
43 through 50, find the following for each function.
Are you looking at the new book?
I'm looking at the Math 111 from Pearson.
Yeah. Okay, so you don't want to do that because that book is different than the one. So you want to look at the scanned copies that I made. So if you go to the content for week 1, there should be scanned copies of the pages that correspond with that particular assignment. And that's what's happening there.
Gotcha.
Okay, so I'm going to put up the new syllabus now, and it will correspond with your e-text.
Okay, so for the page 54 and 61, do you want me to redo them?
No. If you can figure, you don't have to redo it. Just tell me kind of what you did. Leave me a note and say, here's what happened, so I know.
Okay. Well, I really don't mind, so it's all good for me. Okay. What I'll do then is I guess I'll finish the page.
it's not really that big of a deal because problems are problems. So you just got to tell me what you did. So when I start grading it, I'm going, what the heck? You know, but then I understand it.
Okay, I'll leave a note. Don't worry about it.
All right, cool.
All right. Thank you, sir.
You bet. Bye.
Yep.
Could you maybe go over the piecewise functions again? Because none of it has clicked with me.
Okay. Hang on here. So I know I'm gonna mess this up here. Where is? Oh, there we go. Is it Nurus? Nurus?
Yeah, sorry.
Oh, it's okay. So you want to know how you get the book? Is that what you're asking me?
Oh, no, it wasn't me, but I had a question about page 74, number 29.
Oh, okay, sure. So let's do yours, and then we'll do Pamela. So which one did you want to look at?
Page 74, number 29.
So that's the one where we're looking at local maximums and local minimums?
Yeah.
Okay. So it. Okay, so let's look at that negative 2, 0. Do you see the negative 2, 0?
Yeah, negative 2, 0, yeah.
And you see the 2, 0?
Uh-huh.
Okay, so those are the two lower points, right? So if it's the lower points, then those are absolute minimums.
Okay.
All right. So they're not locals. Those are absolutes, because those are the absolute lowest points.
Oh, okay.
Does that make sense? Okay.
And how about the okay.
Now, do you see the 0, 3?
Yeah, I see 0, 3 that's on the top, and the other two is negative 2, and then 0, and then the other is 2, and then 0.
Right. So the negative 2 and the 2, negative 2, 0 and the 2, 0, those are absolutes. So we're done with that. Now the 0, 3, see it's a W function. So that those arrows mean it continues to go. So it's going to grow and grow and grow and grow. So that means that the 0, 3 is a local maximum because it does peak, but it bends, it kind of turns, you know, it goes up and then it turns and goes down. Right, but it's definitely not the highest point because that graph keeps going up.
Okay, so I just have to draw the line, or I have to write number A and B?
You would just say that 0, 3 is a local maximum.
Oh, okay.
And has no local minimums.
Okay, and sorry, how about number 45? Is it the same?
So 45. Okay, so what about 1? Let's talk about 1, 4. Okay.
Okay.
What do you think 1, 4 is? Is that absolute or is it a local?
Which one? 1, 4?
Mm-hmm.
One. So you mean 45? Number 45?
Yeah.
Whose group? So it's maximum.
Exactly, but is it absolute or is it local?
Is it local?
No. Now, okay. So it's the highest point on that graph. So that makes it an absolute.
Yeah, the highest is like 1 and then 4, right?
Yep. So that's an absolute maximum. Because it's the highest point.
Oh. Okay.
All right. Now let's
So,
go.
but it's
So
Okay,
now let's go to 2, 2. Okay. So what about 2, 2?
Okay.
What do you think that might be? Is that in here?
This is local.
Local. Local what? Min or max?
Local minimum.
Yep, you're right. Good job. Okay, now what about 3, 3?
3 is local maximum.
Hey, good job. You're doing great. Now what about 5, 1?
5 1 is local. No, it's local minimum.
No, it's not local because it's the lowest point.
It's yeah, it's the lowest.
Absolute.
It's okay, absolute.
There you go. Yeah, you just, anytime it's the you got those locals nailed, you got that, but absolutes are always going to be at the very highest or very lowest. They'll be absolutely highest or lowest.
Oh, so I have just to write the points if it's absolute minimum or local maximum. That's it, right?
Yep, you just tell me what they are. Yep.
Oh, okay, yeah. That was what I was confused. I'm like, I can draw the line, but what am I going to say?
Okay. Good.
Okay. Thank you so much.
You're welcome. Have a good night.
Mm-hmm.
Is that in here? Okay. So, Pamela, you wanted to talk about piecewise functions, right?
Yes, please.
Is it Latricia? I don't know if she's here or not, but all right. Okay, let's see. Okay, so we'll do one like this. Okay, so it's divided into pieces. So, I think all they're really going to have you do with these, again, is sketch them. It says label 3 points, but I really don't care if you do that. And then find some values. So let's find some values first, and then we can always type them in the Desmos and sketch them up. All right, so let's start with f of negative 3. So the first thing we got to do is decide which condition fits negative 3. So what we want to do is hang on, I'm answering somebody's question.
Yeah, okay.
Okay. So negative 3. So again, does that fit the top one here? Yeah, it does. So then what you want to do is take that negative 3, see, and put it into this function here because it fits that condition. So that's going to give you a negative 6 plus 1 is negative 5.
Okay. I guess I'm just confused how I would know which function to place it with.
Because this function goes with this condition. See, they're both they're in a row. Okay, you wouldn't, so 2x plus 1 goes with that condition, right? And 3x plus 1 goes with this condition. That's how you tell. That's why the first thing I asked you was, okay, -3, which condition does it fit, the top or the bottom? Since it fits the top, then we're going to go to the top function. If it fits the bottom, we'll go to the bottom function.
But why does it fit the top function? I just get so confused by all of this. I've always had a really hard time with it.
Okay, so, well, let's kind of like relax a little bit here, because I think you're kind of trying to confuse yourself a little bit. This, when you rewrite these out, so there's my two pieces.
Mm-hmm.
And the top piece goes with the top condition. So whatever this is, that's when we're going to use that particular function. And when, maybe you're asking me a different question here. I think I understand. So, let's look at this. So maybe I understand. So f is -5, right?
Okay.
Okay. So are you asking me how do I know which one of these fits the -5 part?
Yes.
Got it. So this says x is less than 0, right? X less than 0. Do you see that? Do you understand that part?
Yes, now I do.
Okay, good. So then -5 is less than 0. So then I would use this condition, which means I'm going to use that function. Okay?
Okay.
Yeah, I think I misunderstood your question. All right, now we got it. So 4 is greater than 0. See, this says x is greater than or equal to 0. X, the mouth is always going to eat the biggest thing. That's what they always used to say. Here's the mouth, and it's opening up, and it's going to eat the biggest thing. So x is bigger than 0. All right, since 4 is bigger than 0, then we're going to use this function.
You're going to use that function.
Right.
Okay.
Yeah, they're kind of joined at the hip. That kind of deal.
Okay, and so you're saying our homework problem is mainly going to be just asking questions like this when it comes to these sorts of functions?
Right, and then when it says to sketch them, but you can type that in the Desmos. The only thing when you type it in the Desmos is you got to type it like this. So you go f of x equals, and you're going to get this bracket thing, and you do the condition thing first. All right? Then you go with a little colon, and then you put this. So it's backwards. All right? And I don't know why it's backwards. There's a comma, and then you would put this condition and put the function in second. That's how you type that in. Okay, so it's just the opposite of the way we do it in math.
Yeah. Okay. All right. I think I'm getting a better idea of it. Thank you.
Hey, yeah, you're doing a good job asking questions, and that's what you want to do.
Yeah. Thank you.
Oh, you're welcome.
Lots of questions. I just don't do well in math.
That's all right. Well, a lot of it's confidence, so you'll be all right. Just keep asking. We'll get you through.
Great. Thank you.
Thank
Have a
you.
good night.
You too.
Bye-bye.
Bye.